This is the first of two videos where we learn about relational algebra. Relational algebra is a formal language. It's an algebra that forms the underpinnings of implemented languages like SQL. In this video, we're going to learn the basics of the relational algebra query language and a few of the most popular operators. In the second video, we'll learn some additional operators and some alternate notations for relational algebra. Now let's just review first from our previous video on relational querying that queries over relational databases operate on relations and they also produce relations as a result. So if we write a query that operates, say, on the three relations depicted here, the result of that query is going to be a new relation. And in fact, we can pose queries on that new relation or combine that new relation with our previous relations. So let's start out with relational algebra. For the examples in this video, we're going to be using a simple college admissions database with three relations. The first relation, the college relation, contains information about the college name, state, and enrollment of the college. The second relation, the student relation, contains an ID for each student, the student's name, GPA, and the size of the high school they attended. And finally, the third relation contains information about students applying to colleges, specifically the student's ID, the college name where they're applying, the major they're applying for, and the decision of that application. I've underlined the keys for these three relations. As a reminder, a key is an attribute or a set of attributes whose value is guaranteed to be unique. So for our examples, we're going to assume that college names are unique, student IDs are unique, and that students will only apply to each college for a particular major one time. So we're going to have a picture of these three relations at the bottom of the slides throughout the video. The simplest query in relational algebra is a query that is simply the name of a relation. So for example, we can write a query, student. And that's a valid expression in relational algebra. If we run that query on our database, we'll get, as a result, a copy of the student relation. Pretty straightforward. Now, what happens next is that we're going to use operators of the relational algebra to filter relations, slice relations, and combine relations. So let's go through those operators. The first operator is the select operator. So the select operator is used to pick certain rows out of a relation. The select operator is denoted by a sigma with a subscript. That's the condition that's used to filter the rows that we extract from the relations. So we're just going to go through three examples here. The first example says that we want to find the students whose GPA is greater than 3.7. So to write that expression in relational algebra, we write the sigma, which is the selection operator, as a subscript, the condition that we're filtering for, GPA greater than 3.7, and the relation over which we're applying that selection predicate. So this expression will return a subset of the student table containing those rows where the GPA is greater than 3.7. If we want to filter for two conditions, we just do an AND of the conditions in the subscript of the sigma. So if we want, say, students whose GPA is greater than 3.7 and whose high school size is less than 1,000, we'll write select GPA greater than 3.7. We'll use the logical AND operator, a caret. High school size is less than 1,000. And again, we'll apply that to the student relation. And once again, the result of that will be a subset of the student relation containing the rows that satisfy the condition. If we want to find the applications to Stanford for a CS major, then we'll be applying a selection condition to the apply relation. Again, we write the sigma, and now the subscript is going to say that the college name is Stanford, and the major is CS, again, the AND operator, and that will be applied to the apply relation. And it will return, as a result, a subset of the apply relation. So the general case of the select operator is that we have the sigma, we have a condition as a subscript, and then we have a relation name. And we return, as a result, the subset of the relation. Our next operator is the project operator. So the select operator picks certain rows, and the project operator picks certain columns. So let's say we're interested in the applications, but all we wanted to know is the list of IDs and the decisions for those applications. The project operator is written using the Greek pi symbol, and now the subscript is a list of the column names that we would like to extract. So we write student ID and decision, and we apply that to the apply relation again. And now what we'll get back is a relation that has just two rows. It's going to have all the tuples of apply, but it's only going to have the student ID and the decision columns. So the general case of a project operator is the projection, and then a list of attributes, can be any number, and then a relation name. Now, what if we're interested in picking both rows and columns at the same time? So we want only some of the rows and we want only some of the columns. Now we're going to compose operators. Remember that relational queries produce relations. So we can write a query, say, with the select operator of the students whose GPA is greater than 3.7. This is how we do that. And now we can take that whole expression which produces a relation and we can apply the project operator to that and we can get out the student ID and the student name. Okay, so what we actually see now is that the general case of the selection and projection operators weren't quite what I told you at first. I was deceiving you slightly. When we write the select operator, it's a select with a condition on any expression of the relational algebra. And if it's a big one, we might want to put parens on it. And similarly, the project operator is a list of attributes from any expression of the relational algebra. And we can compose these as much as we want. We can have select over project over select, select, project, and so on.